Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today we're diving deep into a fascinating paper on compiler fuzzing within continuous integration, specifically focusing on the Dafny compiler. It's a really exciting area.
Absolutely. Compiler fuzzing sounds intense. What's the core idea behind this CompFuzz CI framework they've developed?
The main idea is to integrate fuzz testing directly into the continuous integration CI pipeline for the Dafny compiler. Instead of running fuzzing campaigns sporadically, they run short, focused fuzzing sessions for every pull request. This is brilliant because it catches bugs immediately, while the developers who introduced them are still actively working on the code.
That's a smart approach. But I imagine there were challenges. The paper mentions several, right? Like, how long should you fuzz for each pull request?
Exactly. Finding the right balance is crucial. Fuzzing too long bogs down the CI process, but too short a run might miss important bugs. They found a good compromise. A 30-minute, 10-instance parallel fuzzing session seems to be quite effective, based on their experiments. They also had to deal with deduplicating bugs, avoiding duplicates, and making sure fuzzing complements existing regression tests. It's a complex interplay.
And how did they handle deduplication? That's a huge problem in any bug-finding system.
Yeah, big one. For crashes and code generation errors, they used error messages as signatures. But for miscompilation bugs, where the generated code runs but produces incorrect results, it's much trickier. They ended up using the commit that introduced the bug as a signature, which is a conservative but practical approach.
I see. Interesting. So what about bisection? Pinpointing the exact commit that introduced a bug is crucial, especially in a large project like Dafny.
Right. Bisection proved to be a real challenge. The Dafny compiler is constantly evolving, with interface changes and updates to dependencies. Their initial approach using git bisect needed significant adaptation to handle these changes. They had to make their interestingness tests version-aware, accounting for changes in command line interfaces, default flag values, and interactions with downstream tools. It was a major hurdle.
That makes sense. So did they achieve their goal? Did CompFuzz CI find any real bugs?
Oh yes. They found 3 previously unknown bugs in the Dafny compiler, all confirmed by the developers. One was a Java miscompilation with nested arrays, another a crash due to sequence comparison, and a third a parser error. That's a pretty good success rate for a new system.
Impressive. Did their controlled experiment confirm the effectiveness of their approach?
Their controlled experiment, simulating CompFuzz CI on a range of historic Dafny commits, showed that it could reliably find some bugs, especially within that 30-minute time frame. However, they also found that some bugs, particularly those with complex triggers or involving recursion, were harder to detect. This highlights the limitations of the current fuzzer, Fuzz.aid, and suggests areas for improvement.
So it's not a silver bullet, but a valuable tool. What were some of the key lessons learned?
Well, bisection is hard in practice, even with tools like git bisect. Fuzzing too early in a project's lifecycle can be counterproductive, leading to many false positives. And finally, careful coordination between fuzzing and existing regression testing is essential to avoid duplicate reports. They solve this by running fuzzing only after regression tests pass.
That's valuable insight for anyone considering implementing compiler fuzzing in their CI pipeline. It seems like a powerful technique, but it requires careful planning and adaptation.
Absolutely. The paper provides a really detailed account of their experience, highlighting both the successes and challenges. It's a must-read for anyone working with compilers or interested in improving software testing methodologies. And that's all the time we have for today's Tech Bytes and News. Thanks for listening, and goodbye.
Bye-bye.